Welcome, and let me explain how the security process in MariaDB works. So first about me, I was MySQL core developer since 1998. Yeah, my name is at the bottom of the slide. And I was on MySQL security team all this time for 10 years. Well, most of the time actually was the MySQL security team. If you would have written something to security at mysql.com during those years, I would be the one to reply, and if you'd reported a security bug, I would be the one to fix it. And I was creating most of those security processes that MySQL had back then. Since 2010, I work in MariaDB, and again, I'm on MariaDB security team and help to create those security policies that we'll be talking about later on this talk. I'm also a VP Server Engineering in MariaDB Corporation and a board member of MariaDB Foundation. So, how do we get information about security issues? Where do we get them from? First, they could be, of course, discovered internally. We have a team of testers who routinely find and report new bugs, and some of them could be actually security related. It doesn't happen very often. Most often we get security issues through the security@mariadb.org email address. So if anything comes there, it's usually a report about security vulnerability, not necessarily valid. We have a project at HackerOne, and this is what it looks like. And that's where hackers on this site can report security issues and get their reputation increased. And also we watch Oracle critical patch updates. This is where Oracle reports about security vulnerabilities and assigns CVE numbers in Oracle products, such as MySQL. This is what Oracle typical CPU looks like. CVE numbers, products, some rough risk matrix, and what versions weight was appeared and fixed. So mostly we get our CVEs from Oracle critical patch updates. Those are issues that affect both MySQL and MariaDB. Although as time goes on in the last years, the code base of MariaDB and MySQL diverges, and we get less and less CVEs during this path. As for MariaDB specific CVEs that we get through security@mariadb.org and HackerOne, we get 1 to rarely 3 MariaDB specific CVEs per year. So what do we do with them? Well, we fix them obviously, and we follow the responsible disclosure policies. That is, if not only MariaDB is affected, but the bug issue is reported to us, then we coordinate with all affected vendors. If MySQL is affected, we talk with Oracle. If Percona server is affected, we talk with Percona. If Galera for MySQL is affected, we talk with Codership. And Codership and Percona also report issues to us if MariaDB is affected. Oracle doesn't, but that's why we watch CPUs. Then we don't, of course, disclose the issue immediately, and we always ask the security researcher who reported to us not to. There's always a disclosure embargo, which is agreed on by all affected vendors, and until all the affected products has released new fixed versions, that embargo and the details will be not known. But after everybody has released, after this agreed on embargo, then we usually try to do a full disclosure. We also talk with Linux distributions, particularly with Debian and Red Hat security teams, but with others as well. And full disclosure, it's particularly what is very much appreciated by Linux distributions, because they have very capable and knowledgeable security experts and their security teams. They want to know what the problem was. They want to know if distribution needs to do anything. They might want to know if they need to port the patch somewhere else if something else is affected. They very much appreciate that we do full disclosure. So what is our actually MariaDB security policy? It's we have a very small and simple security policy, but at the same time it's quite clear and unambiguous, and I would say objective. That is, we cannot say, okay, we think it's critical, but very few people are affected, so let's say it's not very critical. There's no such subjectivity in our criteria. If the issue is critical, if it matches those rules, then it is critical, and then we do as the policy says. So it's on the slide, but let me still read it aloud. So we classify all security issues in two groups. There could be a critical security vulnerability. A critical is an exploitable vulnerability that causes arbitrary code execution or allows an authenticated user to crash the server or get access to the data. And it's very concise, so every word here is important. For example, that vulnerability has to be exploitable. If it's only a theoretical possibility, but there's no way to exploit it, then it's not critical. If there's a crash or get access to the data, then the user has to be unauthenticated. If you need to log in into MariaDB specifying username and password, then it no longer classifies as critical. All critical issues, we fix them at once, and we release new fixed version of MariaDB ASAP, usually within a few days. And yes, I can say that this policy is in place for the last 10 years, and there was never, not a single case when we didn't execute this policy. Every time when we had critical vulnerability according to those criteria, we always released fixed binaries immediately. So this is something you can very much rely on. There might be some other rules that we didn't follow as exactly, but this one we absolutely follow all the time and never break, and never did break. All security vulnerabilities that don't classify critical, they are considered medium, and they are also fixed usually at once, and fixes will be in the next planned release. That is, we do not change our release schedule because of medium security fixes, but we do promise that all security vulnerabilities will be fixed in the next release. It doesn't matter if it's critical or medium, any security vulnerability will always be fixed in the next release. Whether it's critical or medium only affects how soon the next release will be. And so how soon the next release will be, that's how our whole release scheduler is based on security, is specifically tailored to provide as fast as possible release of security fixes whenever we know about them. And because Oracle releases this Oracle Critical Patch updates 4 times a year, and we don't know about those issues until Oracle releases, we create our release scheduler so that our releases immediately follow Oracle CPUs. Basically, directly after Oracle releases CPUs and Oracle releases the next version of MySQL, within a few days or a week, we release MariaDB releases with all those issues fixed in MariaDB that were fixed in the corresponding MySQL version. So this is created specifically to minimize the time when the security vulnerabilities are already known to the world, but not fixed in MariaDB yet. So following the Oracle CPU scheduler, MariaDB releases usually happen in the last week of January, April, July, and October. So if it's a medium security vulnerability, then you can expect, when you can be sure that it will be fixed in the next release, which will be in the last week of January, April, July, or October, whichever comes first. So to wrap up, those are links where you can learn more about how we do or information about security in MariaDB. So this is the link to our security policy. This is exactly what I just said with critical and medium and when we fix that. This is our project on HackerOne, which also says the same thing about critical and medium, but also has a lot more details about what part of MariaDB, what vulnerabilities are in scope, what are out of scope, what rules we follow when we release, how we do responsible disclosure, how we communicate with vendors. All this is explained here in our HackerOne project page. If you've seen the Oracle CPUs, they can contain those CVE numbers that identify vulnerabilities. So users often want to know, in particular Linux distributions, in what MariaDB a particular CVE was fixed. So we maintain a page in the knowledge base which for every CVE lists when it was fixed in what MariaDB version and what connector version. And some of those CVEs that Oracle lists, they simply do not apply to MariaDB because, for example, Codebase has diverged. We maintain a separate page of all CVEs that were fixed in MySQL but never existed in MariaDB. That's a separate page, and pretty much every CVE that was listed in corresponding MySQL pages or Oracle's views, it's present in one of those two pages. We've actually got a few praises from various security teams in Linux distributions about how good it is, how well we maintain all those pages, so they don't need to do their own research. They can very quickly look up a CVE number and find out whether it was fixed or it was not applicable. So that's basically what we do with security vulnerabilities. That's how we handle them. Now let's talk about it.
Hello to Sergey Golubchik. Thank you for an interesting presentation overview on security. So you mentioned that you started with MySQL back in 1998, and then you've been with MariaDB since 2010. How did you get into security? What were you doing before that?
It was topic always interesting to me years before 1998. So I was interested in security, in protecting other programs, breaking other programs, stuff like that. So it was rather natural. I paid close attention to how MySQL was doing in the area of security. So I was just starting replying to those mails and fixing security bugs in MySQL, and people were reporting them.
So 22 years is a long time. Have you seen what sort of changes have you seen in the industry over that time?
In the industry of security?
Yes.
It became an industry with lots of people working there, all highly specialized in their particular part of that instead. So, and I stopped being up to date with what's going on there many years ago. You just cannot actively follow if you don't work there all the time, and I don't. I'm working on databases.
So you mentioned that there were about 1 to 3 MariaDB specific CVEs each year, and that's quite a small minority of them. How many CVEs are we talking about overall?
Well, I don't know. I can't say for sure. I would need to look into the security page that I mentioned, but I think it would be maybe about 20, 30 maybe. All the rest coming from Oracle CVEs.
And how many of those are critical versus medium?
None. Well, none of them they cannot be critical coming from Oracle CVEs because, well, we don't do emergency releases for them because our releases are scheduled to be released immediately after Oracle CVEs, so it doesn't make any difference whether it's critical or not. They'll still be in the same release. Oracle releases MySQL version, they release this CPU, and then we immediately do. So if we learn about the security bug between Oracle CPU and our release, it doesn't matter whether the issue is critical or medium, it will still be in the release in the next few days. In that sense.
And if it is critical, do you think that MariaDB does enough to highlight to users that there's a critical issue that they should urgently update?
Well, generally, if we do an emergency out of unplanned release, we do a blog post just to explain users why we did the release so that they wouldn't, freak out. They would understand why this an unplanned release. It doesn't apply to security release only. We did a non-security related unplanned release mid-November. We also did a blog post to explain what it was about. So if we do an unplanned security release, we also either we explain or sometimes somebody else blogs. Like last time, I think Percorna blogged about to two CVEs, and we did an emergency release having those fixed.
Okay. And then you mentioned that we work reporting issues to Oracle or to Codeship or to Percona as needs be, and that Percona and Codeship do the same back to us. How complex does it make your life, the fact that Oracle don't report those CVEs to us, that you have to look them up yourself?
That is not the thing that Oracle doesn't report to us isn't a big deal, because we've already scheduled our whole release process around Oracle CPUs. So we basically release anyway after Oracle CPU. So that's not a problem. What is the problem is that Oracle, I have no idea to know what security issues were fixed in every MySQL release. What were they about? So I read those CPU tables that I've shown on the presentation, let's say like high, medium version. And then I look at the changes in MySQL code, and I try to map those changes if they make any sense as this vulnerability with this particular values in the table. Sometimes there's a vulnerability, there's a CV that does not map to any changes. Sometimes there's a CV that maps to many different unrelated changes. So it's always a guesswork to try to understand what particular vulnerability was about. Sometimes I see the change, but I cannot understand what bug caused it, because there's no test cases, there's nothing. So they don't disclose any information about it. And I know for a fact that security teams in Linux distributions, well, not all of them, but some of them, they do the same guesswork. They also try to map MySQL code changes to CVEs to understand what the vulnerability is about. Sometimes we discuss and share the information and trying to make our guesses more precise by doing this guesswork together. So this is the problem. But the fact that they don't report it to us immediately, that's not a big deal.
Okay. Then in the definition of critical versus medium, one of the criteria was exploitable versus maybe it's just a theoretical possibility. Is there any scope for subjectivity in that? Maybe are you sure always whether something is exploitable or not?
Yes, absolutely. But generally, in this case, I'm trying to be on the safe side. And if I don't know how to exploit it, but it looks like kind of sort of exploitable, possibly for somebody who knows better about this, then just let's treat it as exploitable. So, if in doubt, that's exploitable. Yes, yes, I think we've seen something which was purely theoretical, but most of the time they look like exploitable, even if there is no actual exploit.
Okay.
It looks like most of the time it looks like somebody with a better knowledge of the area could have written an exploit for.
Right. So I've seen situations where it seems that companies are following either their company checklist or some sort of third-party checklist, security checklist, so criteria that must be met in order for software to be seen as safe to be deployed. And sometimes I've seen you responding in a way that's, well, is this issue really practical versus is it just something to tick off on a checkbox? Do you come across that kind of thing quite often, where there's a sort of theoretical checklist versus a real practical issue, and how does MariaDB handle that?
Well, generally we are not particularly. Well, we prioritize fixing issues as compared to something which is just a checklist issue only. But sometimes we do fix those checklist issues too, because if the customer has no other way, they either won't use MariaDB or MariaDB must have this checklist feature, then sometimes we implement them too. But given the choice, we prioritize the actual security improvements over something that only creates a false sense of security.
Right. The MySQL native plugin that was introduced back in MySQL 4.1, and that's based on a hashing algorithm based on SHA-1. So MySQL introduced SHA-256, and MariaDB introduced ED25519, which I think is the same algorithm that's used by OpenSSH. What was the reason for the different choices there?
Well, first, the OpenSSH uses lots of different algorithms. It also uses SHA2 and ISA. So both we and MySQL, we use the same algorithm that OpenSSH is using. So the story is, it's actually explained in my blog post about at MariaDB.org called, I think, Who Are You? The history of MySQL authentication algorithms or something like that. Hope there will be a link under the video somewhere down there. And so the story is this SHA-1 that we've used, it's double SHA-1. It was started to be perceived as unsafe, and MySQL went and implement an RSA-based approach where the password is encrypted using this asymmetric encryption RSA algorithm and sent to the client. And locally, it's hashed using SHA-2. And we use this elliptic curve signature algorithm ED25519. So the problem was with MySQL 1, so I didn't like that the client sends the password to the server completely in the original form. That is, the server will exactly know what your password is, and the malicious server will, well, basically know your password. That was the problem with historical MySQL authentication algorithms, including the one with SHA-1, and it's still the problem with the newest one in MySQL, and I didn't like that. So we've invented and implemented a different authentication algorithm where the server does not get my client's password at any point in time ever during authentication.
So given that, given the problems with the original MySQL native password authentication, why is it still the default authentication when you use password login?
Because there's no problem with it yet. So the problems are, well, there are two problems with it. One is that people just don't like SHA-1. And second is this checkbox one that you mentioned earlier. Some organizations might have a security checklist with the box, don't use SHA-1. That's the only two reasons why somebody might not want to use MySQL native authentication, because currently it's still as secure as it was before. The non-attacks about SHA-1, about finding collisions, they do not apply to this authentication. They do not make authentication less secure. They allow you to find two different passwords that will hash to the same, well, password hash, but so far they do not allow you to find the password that will map to a given hash. If you in advance can find two different passwords that will have the same hash, it doesn't really help you to break the authentication and find the password for any given hash.
Okay.
So it's quite likely that eventually, maybe very soon, SHA-1 will be completely reversed, but it didn't happen yet. So far, it's still safe.
So MariaDB 10.4 introduced Unix socket authentication, at least for Unix systems. What are the advantages of doing that versus the password authentication?
So the advantage is, so the best authentication is the one when you don't need to, the best way not to forget the password, not to choose a weak password, not to lose it somewhere. It's just not to use any password at all. And Unix socket authentication, it does exactly that. There's no password. And where MariaDB, it simply trusts your operating system to do the authentication for you. You need to type your password to log into your Unix box or SSH into it, or I don't know, whatever other authentication your system uses. But after you successfully manage to log into a system, then MariaDB server simply trusts your operating system to tell who you are. Because you have already authenticated once, you don't need to do it twice using different password or the same password. And we use it now by default for the root user because the root user already has all the privileges there is. It can see all the data, all the database files. It can modify them. It can see MariaDB process in memory with everything in it. It's not really, doesn't add any additional security to require the user to enter any additional password to log into the server, because the root user already has full control over it.
Are there any situations where it's a disadvantage to use, where the person would be recommended to disable it?
To disable it?
Yes, well, or not to use it to remove
yes,
password.
Of course. So because Unix socket plugin, it makes MariaDB to trust the operating system to tell MariaDB who you are, basically what your local username is. So if you have many users all acting from the same local username, same local Unix account, but they should be working under different database accounts, then Unix socket won't help you. I think we have a knowledge base page. Maybe there should be a link down there as well, which was recently extended to explain all those cases when Unix socket is good and when it should be preferable and when it does not work very well. Configurations doesn't work. It should all be in the knowledge base now.
Well, I think that's all we have time for. So thanks, Sergey, for joining us here in the Minifest and for your presentation and for your Q&As. And until next time.
Thank you for having me.